Okay, there's been a lot of confusion in class, hello, about tape diagrams. So I kind of just want to go through some of the examples that we went through in class just to try to cement some of these ideas in your head. So if I want to make fruit punch is parts apple juice, parts orange juice. So if I put in 4 cups of apple juice, I need to put in 3 cups of orange juice to get fruit punch. Okay? So if I were to draw this as a tape diagram, I'd write apple juice, I'd draw 4 pieces, and I would draw orange juice, and then draw 3 pieces. Okay? So this is how my general tape diagram is going to go. Now, let's look at it. If the total volume of fruit punch is 630 milliliters, find the volume of apple juice Megan uses. So what it's telling me is if I take the apple juice and the orange juice and put it together and get 630 milliliters, that's how much fruit punch I need to make. So I need to know the recipe calls for 4 to 3. So since I know that I have 1, 2, 3, 4, 5, 6, 7 parts, I take my total and divide it into 7 parts. This is what's going to tell me what each part is worth. So I know 7 goes into 63 9 times with a 0, and that tells me every box is worth 90. This tells me I need to take 360 milliliters of apple juice and 270 milliliters of orange juice to get 630 milliliters of fruit punch. Okay, so that's what happens when I have a total and I need to split it up. Now what happens if I just have apple juice? I don't have orange juice and I want to figure out my total. So let's look at that. Okay, so let's erase this. We're going to use the same tape diagram. Oops, I went too far. Oh no. Okay, so here's my tape diagram. Now, it says I have 520 milliliters of apple juice. So just this line, just apple juice, is equal to 520 milliliters. Okay? I want to know how much orange juice I need. Okay? So if I know that just apple juice, just 4 parts, are worth 520, that's what I'm going to cut 520 into. So 4 goes into 5 one time, 1 left over, 4 goes into 12 3 times, don't forget the 0. This tells me that each of these are worth 130, which makes sense because if I take 130 and I multiply it by 4, I get 520. Now, since all the parts are equal, I'm going to fill that in. And this tells me that I have 390 milliliters of orange juice because I have to take 130 and multiply that by 3. Okay, so let's look at another example of doing these two types of problems. It says a box contains baseball and football cards. The number of baseball cards to the number of football cards is a ratio of 5 to 1. So baseball to football is a ratio of 5 to 1. I'm going to draw that tape diagram. Notice that my boxes are approximately the same size. Now it tells me my total is 1,380 cards. That's how many total cards I have. I want to know how many baseball cards I have and how many football cards I have. So if I have my total, I'm going to break it up into the amount of total parts I have. So I have 1, 2, 3, 4, 5, 6 total parts. So if I take 1,380 and divide it by 6, I'm going to get 230. This means that each box is worth 230 cards, each part. Okay? In baseball, I'm going to take 230 and multiply it by 5. So I have 1,150 baseball cards, And I'm going to take football cards, 230, and multiply it by 1, and I'm going to get 230. And that's how much of each card I have if I use the same ratio. This is pretty much like this last, the last section when I have 5 to 1. This says that this is 1,150 over 230. Okay, it's really the same thing. Okay, and I'm going to be multiplying 5 by 230 and 1 by 230, and that's going to give me my equivalent ratio. Let's do one more problem with the football and baseball cards. Suppose the number of baseball cards is 950. Again, my ratio is 5 to 1. So let me redraw my tape diagram. And it says I have 950 baseball cards. So only this line of baseball is worth 950. So I have one, sorry, I got a little box crazy. I have 1, 2, 3, 4, 5. So I take my 950, divide it into 5, and I get 190 per box. So in every box, I'm going to write 190. And this tells me that I have 190 football cards also, because I'm going to take that 190 and multiply it by 1. This is the first part of looking at real-world problems with ratios. Look for the next video to look for three ratio tape diagrams, and look to future videos about what happens when my ratio changes. If you have any questions, ask in class. Other than that, have a great night.